Welcome you all for another presentation on another important electronics subject, that is electromagnetic field theory. In short, this can be called as EMFT, electromagnetic field theory, or sometimes also called as EMTL, means electromagnetic and then transmission lines, right? This is electromagnetic field theory, right? So basically, the electromagnetic field theory describes about both the electric fields as well as the magnetic fields, right? So it has two parts basically. One is electrostatic, you can say. One is electrostatics, and the second one is magnetostatics. Magnetostatics. Therefore, your electromagnetic field theory, actually it is one of the very interesting and very important subject. Normally will be included in for electronics and communication engineering graduates, as well as it will be there for electrical and electronics engineering also, and even for electronics and instrumentation engineering graduates also, right? So this electromagnetic field theory normally plays a very important role in many applications, even in our day-to-day life applications also. So, especially if you uh, see that in satellite communications, in radar communications, as well as in biomedical communication, biomedical or medical applications, normally the electromagnetic waves will plays very important role actually. So in the form of EM wave, the signal can be transmitted, and from by passing that signal you will get a certain output. I mean certain quantity will be obtained, and by analyzing that you will get relevant information, right? So therefore EM waves is a very important discipline where especially in communication fields it will be very much useful, right? As the name itself suggests, that electromagnetic means it includes both electric field or electrostatics or electrostatic fields, as well as the magnetostatics or the magnetic fields. It is the combination of both electric field as well as the magnetic field, right? Therefore the combination of these two gives rise your EMFT or EMTL, right? That is what. Very nice. Now let us see what are the basic important things that normally we will see under this electrostatics, and similarly what are the various parameters normally we can see under this magnetostatics, right? If you consider the electrostatics, actually it starts from the basic source of the element is electric charge, right? So the very important is that the electric charge, the main source is nothing but the electric charge or the charge. Simply you can say the electric charge, that is the very important. And the another important parameter is okay, force, I mean electric force, or otherwise also called as EMF, or otherwise you call electromotive force. Electromotive force, that is denoted by the letter F actually, electromotive force, or simply electric force, that is the second parameter. And then the third one is electric field intensity. The third parameter is electric field electric field intensity. Electric field intensity, that is denoted by the letter E. And then electric flux density, right? What is that? Electric flux electric flux density, and it is denoted by the letter D normally. So these are the basic various important parameters that can come across under our electrostatics or electrostatic fields. And similarly, if you consider the magnetostatic, similarly you will have, okay, here you will have, here electric charge will be there, whereas here the magnetic flux, you can say magnetic flux will be there, magnetic flux, right? That is the first parameter. And then magnetomotive force, mmf, it is magnetomotive force is the second parameter. Here is the electromotive force, where here is the magnetomotive force, and the third one is, okay, so magnetic field strength, the third one is magnetic field strength, magnetic field strength, that is called as H, magnetic field strength. Here let us say electric field intensity are also called as electric field strength. Remember that electric field intensity E can also be called as electric field strength. Similarly, here the magnetic field strength denoted by the letter H are also called as magnetic field intensity, and then magnetic flux density, and the another parameter is magnetic flux density, that is denoted by the letter B, capital B. These are the very important standard notations that is to be used under this electromagnetic field theory, right? These are the basic important parameters which we normally come across under magnetostatics, and these are the electric parameters actually, right? So we must know, or we must be familiar with these little bit parameters, so that you can very much easily you can understand the concepts of this electromagnetic field theory, right? This is what. And if you go a little bit further, and now what is there, if you consider this entire electromagnetic field theory, this entire subject or the electromagnetic field theory, okay, it moves around four important laws actually. There are very important laws are there. There are four important laws are there. If you understand those laws, if you can analyze those laws, you can easily understand the concept of the electromagnetic field theory subject, right? So most of the students normally can feel very difficult to understand this subject, right? And sometimes many people can feel some confusion or some they can, most of the time they may irritate also. Here nothing to feel like that. It is very interesting, very interesting actually. Only the thing is we need to study, we need to understand the basic concept in a meaningful way. If you can understand the purpose or the main weight of that particular parameter, and obviously there will not be any confusion, right? So therefore, what is the first law? There are four important laws are there, as just now I told you that four important laws. There are four important laws are there as far as our EMTL or EMFT subject is concerned. The very first law is that Gauss law. In brief, just I want to convey you actually Gauss law for electrostatics. Gauss law for electrostatics. Gauss law for electrostatics or for electric field. What is Gauss law? That I will explain you in the next subsequent presentations. In this presentation, I would like to give you the basic important information that is required to understand for this electromagnetic field theory subject, right? So our entire electromagnetic field theory involves four important laws only. So out of those four laws, the first and foremost is Gauss law. Gauss is the scientist name actually. He derived one law that I will explain you in the subsequent presentation. That's why for this law his name was included. So Gauss law for electrostatics. Okay, for electrostatics. And the second law is same Gauss law for magnetostatics. What is Gauss law for magnetic fields? You can say magnetic fields, no problem. Magnetic field. That is the second law. What is the third law? You know, third law is the Ampere's law. What is Ampere's law? Ampere's law, also sometimes called as Ampere's circuits law. Ampere's circuits law, both are same. There are two names normally. Ampere's law or Ampere's circuits law, that is the third law, and the fourth is Faraday's law. What is that? Faraday's law. So this is the fourth law actually. Okay, collectively, so these are the four laws, very very important laws, around which total our subject will revolves actually, right? Therefore, first is the Gauss law for electrostatics, Gauss law for magnetostatics, Ampere's law or Ampere's circuit law, as well as the Faraday's law, right? So these are the four important laws basically, and collectively, you know, these four laws are also called as Maxwell's equations. These laws can also be called as Maxwell's equations, right? Maxwell's equations. Maxwell's equations. This is one of the very very important unit, right? If you see your a syllabus of this particular subject, if you see the first and the second unit covers about the electrostatic fields. Normally for any graduates, engineering graduates, if you see the syllabus of this subject, the coverage of your syllabus of this particular subject according to university, I think the first two units covered for these electrostatic fields, and remaining the remaining two units, subsequent units, will be covered for these magnetic fields, and the next unit definitely it will be Maxwell's equations. Means it is the combination of both electric field as well as the magnetic field. Okay, under this Maxwell's equation you will study elaborately about these four laws actually. And again, these laws can be given in two different forms actually. So that is called Maxwell's equations in differential form, and then second is the integral form. There are two forms. So these equations, okay, these laws, for each law you will have one particular equation actually. Okay, for each law you will have one particular equation, and that equation is available in differential form as well as integral form. Okay, therefore sometimes it will be asked in your examinations, explain the Maxwell's equations in differential form, and similarly explain the Maxwell's equation with their statements in integral form. Then so in the integral form you need to give all those four equations by mentioning the statements of those laws. If you are asked to explain about the Maxwell's equations in differential form, so the differential form can also be called as the point form, right? Point form, also called as point form. Point form, also called as differential form. Differential form means d by dx or delta, you can say. That I will explain you very neatly in the subsequent presentation. So for the time being, you just remember that your EMTL is nothing but it is the sum of these four laws actually. Combination of these four law is equal to your EMTL subject. That's it, or EMTF, whatever it is. If you know these four laws, then obviously you are very much familiar about your electromagnetic field theory subject, right? So therefore Now let us enter into the electrostatic field. Let us we start about the electric field, because that is the first part of this subject actually. What is the electrostatic field? Let us see one important definition. Okay, and thereby we will go further actually. What is the electrostatic field? Right, let us see the electrostatic field. So in electrostatic field, it describes about the electric field actually. It describes about the electric field, and obviously for this electric field, the main source of electric field is the electric charge. You know, the electric charge is denoted by the it is denoted by the letter capital Q, or sometimes small q also, nothing wrong in that. But for as far as our subject is concerned, EMTL is concerned, I will give the notation capital Q. In most of your textbook also it will be followed with this notation only, right? So in this electrostatic field, the main source of this electric field is the charge Q, right? So now let us define one particular important law here, that is called as Coulomb's law. That is the very important law, the basic important law for this electrostatic field actually, that is called Coulomb's law. Coulomb's law. What is Coulomb's law? What is Coulomb's law? Coulomb's law states that, let us consider there are two charges, let us say Q1 and Q2. Let us say Q1, this is Q2. These are the charges, electric charges. Just now I have told you that these are the electric charges, let us say having the same magnitude. Okay, and also called as, these charges can also be called as point charges. Okay, so there are two charges, let us say Q1 and Q2, and these two charges are separated by a small amount of distance d, small d, right? Two charges are, we are considering two charges, they are separated by a small amount of distance d. Then there exists some electromotive force will be exist in this, between these two. Electric force will be developed. Okay, some F, electromotive force, or simply electric force you can say, or electromotive force will be produced whenever if you place two charges with a small amount of distance d, right? And this force is obviously the force whatever is generated between these two charges, that is directly proportional to product of two charges Q1 and Q2. The force, whatever the force generated, that is directly proportional to the product of two charges, nothing but Q1 into Q2. This force is directly proportional to the product of two charges, and similarly this particular force is inversely proportional to the square of the distance between those two charges. This is another relation. This is equation number 2. Clear? The first equation is for force. This force is directly proportional to product of two charges Q1 and Q2. Okay, similarly this force is inversely proportional to 1 by square of the distance. Okay, then if you combine these two equations 1 and 2, you can write in a single statement F is equal to, how you can write, tell me? If you combine equation 1 and 2, equation 2, from equation 1 and equation 2, you can write that F proportional to, how we can write, Q1 into Q2 by d square. Can I write like this? This is, you can call it as equation number 3, right? Because if you combine these two, obviously q1 q2 by d square. Here what we will do, you remove this proportional, right? You need to insert one constant, that is called proportionality constant, and that constant I will call it as some k, let us say, right? So from this equation, if you remove that proportionality, then I can write like this: f is equal to some constant k into q1 into q2 by d square. Okay, here k is called as proportionality constant, where k is called as, what is k? It is called proportionality constant. Proportionality constant, and this value is given by k is equal to 1 by 4 pi epsilon. 1 by 4 pi epsilon, that is the value of k. Therefore, substitute that value here, then your f is equal to, normally it is q1 into q2 by, if you substitute that, 4 pi epsilon into d square. This is what your f, and this particular relation, right? So you can call it as 3, and you can call it as equation number 4, whatever it is, no problem. This equation number 4 is called as Coulomb's law. This particular equation is called as Coulomb's law of electric force. Coulomb's law of electric force. This is very, very important. Very, very important. Where epsilon is the permittivity, where epsilon is called as, you know, what is epsilon? Epsilon is called as permittivity. Okay, permittivity, and also called as dielectric constant. You know, it is called as dielectric constant, right? I hope it is enough for today's presentation, and we'll continue in the next presentation. I hope you understood the basic concept of this, whatever still we have seen, right? So I think I will finish off this presentation here, and we will continue with many more important information regarding this electric field, as well as the different things whatever we have seen, that is electric field intensity, electric flux density, and all these things we will see in the subsequent presentation. I hope you understood well, and I request you all that to comment or to give your valuable feedbacks. You can comment on my channel, so that it will be very much helpful for me and for us to improve this, and so that many of you, many students across the country, across the globe can be benefited. Okay, so they can understand the subject very easy way, thereby you feel very fruitful, right? So with this, we'll finish off this presentation. We'll meet in the next presentation. Have a good day.